Okay. All right. Good afternoon, everyone. I'd like to welcome you to Building Number Sense with Subitizing. My name is Lindsay Herlihy, and today we're going to take a look at one of the most important parts, in my opinion, of developing mathematicians, young mathematicians. This really focuses on pre-K2 mathematics, but the concepts that we'll be looking at today are important for not only preschool and early elementary, the primary grade levels, but what students develop in those areas in terms of number sense really makes them strong mathematicians as they head into later elementary years, middle school and high school. So this is a very important concept, and we'll kind of take a look at why. I'd like to remind you that at the end of this session, you can download this presentation where you will see all of the resources that have been linked and the activities that we'll kind of go through today. All of that is available for you. So I will make sure to point out where you can access those as we go on. All right, a few things that we are going to take a look at today. The first thing when we talk about building number sense is we're going to think about subitizing and what that is and the stages of subitizing. We know that when we think about developing number sense in our students of any age, what we're looking for is students that are able to use numbers flexibly and efficiently. And that is very, very important in order to be a successful mathematician. We're also going to look at how subitizing lays the foundation for later success in mathematics. So often whenever we think about subitizing, it just seems so simple, like something that just young kids would do, but that's not true. Because what early childhood teachers do in terms of developing number sense and subitizing and the littlest mathematicians that we have really impacts how even second grade teachers are able to do subitizing with some of the math concepts that they're exploring. So we're going to see how one of you who is an early childhood teacher supports another one of you who could easily be a second grade teacher. We're also going to look at, again, some exercises. So if you were in my previous session, which I think all of you were. So you will see some examples that are repeats of that, but you'll also see some new information for us to take a look at. Simple ways to incorporate subitizing exercises into the classroom. So those are going to touch on a variety of different ways we can look at subitizing. Subitizing doesn't just have to be done during your math time. In fact, it should be done during lots of different times. Especially there's opportunities during transition times, during science times, lots of great ways that we can incorporate subitizing. And like I said in my last session, one of the big things to remember about subitizing, if you take nothing else away, is that subitizing can't be taught, it is caught. So the only way to really develop that subitizing and number sense in your students is to give them repeated exposure to it. Lots of different ways to engage. Okay. All right, so we are going to start off one of the best ways in order to look at what is subitizing is to do subitizing. So again, I'm going to show you 3 very quick images. We will remember that this is recorded. So for those of us that are here, this might be a little bit of a repeat, but for those of us that are new on the recording, this will be a great experience to show you what exactly subitizing is. So I'm going to show you very quickly 3 images. They're going to flash on your screen. You will not have time to necessarily count them, but I would like you in the chat to tell me what you see. So again, it's going to happen really quick and you need to be paying attention. We go. All right. So in the chat, if you can tell me really quick what you saw. Good, 4, 2, 5, excellent. All right, nice job. A 4, a 2, and a 5. All right, very nice. So Those are absolutely correct. When I go backwards and take a look at this, I see 3 different images. You saw a 4 die pattern, you saw a 2 finger representation, and you saw a 5 10 frame. And you may not have been able to count that 10 frame, but as educators that probably use 10 frames on a daily basis, you knew that that top row, if it is filled in, it is a 5. Every time, you can always count on it being 5. It's never going to change. And this is exactly what subitizing is. When we think about what subitizing is, when we try to define it, it is by instantly seeing that many. So my question to you is, well, how did you know? You didn't have time to count it. So how did you know exactly what those numbers were? All right, so usually when you go through, we see that we know these numbers because as adults, we've worked with them many, many, many times. We've played board games forever that use die, and we're really good at recognizing when we roll that die, we see a 6 or we see a 4, and we don't have to count it. This is what we're asking students to start understanding and to develop, a skill that we're asking them to develop, which is subitizing, being able to instantly see how many. And one of the most important parts about subitizing is not that students get that practice seeing quick images that show them how many, but also that they're able to take that and apply it to different representations. So we want to practice subitizing with them, not only in die patterns, which are very common, but also finger representations, tally marks, 10 frames, rec and rec patterns. We want them to see it in a variety of different ways. Yeah. All right. So since we know what subitizing is, this is not a new concept. It was coined in 1949 by somebody that we all know, okay, Jean Piaget, very popular constructivist educator, and really looks at the way that children learn. Subitizing comes from that Latin adjective subitus, which means sudden, and it is defined as that instantly seeing how many. We want students to be able to look at an image without having to count it. And we'll talk about, and I'll give you a very concrete example of why we don't want students to rely on counting at past a certain point, or perhaps past a certain level of experience in mathematics. But we will get to that in a little bit for those of you that are interested in that whole counting versus subitizing idea. And subitizing, like I said, is not new. It's been studied by researchers for a long time. What's interesting about subitizing is that some research will argue that subitizing comes before counting. And the reason that they say that is because when researchers were initially looking at this, there's actually proof that infants know how to subitize. So in the study that we kind of referenced, there was a very young child, like 6 months old, was placed in front of 3 different images. One had no dots on it, one had 1 dot, and one had 2 dots. And the researcher that was conducting the activity would clap their hands. And they noticed that the infant's eyes, who obviously had no experience with much mathematics and counting, when you clapped your hands 1 time, the infant's eyes would go to the sign that had 1 dot on it. When you clap 2 times, it would go to 2 dots. So what researchers and educators were trying to figure out is just what comes first. Is it the subitizing or is it the counting? Subitizing is seen as an efficient way to count. So it's kind of a chicken and the egg thing, but we do know that they are closely related and they support one another. There are 2 different types of subitizing. And in the last, in the Young Mathematician session, I touched a little bit on this, and we're going to spend some time kind of really going over this. So 2 types. The first type is perceptual subitizing. That is when what we just did, instantly recognizing a number without using other math processes. And typically we see this in students that are of preschool age. Now, like everything else that goes with child development, and the study of mathematics, not all students develop at the same rate. They usually develop in a series of predictable patterns, but not necessarily at the same time. Infants tend, and up to like 2-year-olds tend to be able to subitize up to 3. Adults can obviously perceptual subitize to 5. And preschoolers, by the time, usually, if they've, again, had enough exposure, they will be able to subitize to 5 as well. So that is kind of the benchmark areas for perceptual subitizing. And again, it's just being able to instantly see how many. Now, like I mentioned in the last session, for this type of subitizing, because you're working with students that are so young, you often need to give them permission to subitize. When I would play games with my daughter, we play with a big die that has like the dots that she, when we were initially practicing this, would count. And she would touch each dot to count the quantity. I had to give her permission. If you know that that's a 5, you can just tell me it's a 5. You don't have to count it every time. And then it's kind of fun because then you say, well, how did you know it was a 5? And they have to kind of give you some, how they see it, like what are the characteristics that tell them that it's a 5. So sometimes you need to give kids permission. I will also say this, Christina Tondevold, who has, I'll put her name in the chat, for those of you that are building your Math PD specialist list. Christina Tondevold is a fantastic math specialist that provides a lot of PD. I'll reference some of her materials here in this session. She calls herself the recovering traditionalist, which I love because many of us experience mathematics in a traditional way where we were taught with equations and flashcards and time tests. And now we're working really, really, really hard to explore mathematics and teach children in a different way. So I just love the name Recovering Traditionalist. But her math resource center is called Building Math Minds. And she does a lot of talking about subitizing and how to build number sense. But one of the things that she addressed in one of her sessions and conferences that I was able to attend is that when it comes to subitizing, it not only depends on the age and the mathematical experience of the students, but it also depends on their personal life experiences. So for example, some of us teach young students in areas where their home life is not necessarily predictable. That might mean that their living arrangements are not predictable, the adults that they live with are not predictable, their daily activities are not predictable, or I should say unstable. There's not a lot of trust that is naturally built into their lives. What was discussed when we were talking about subitizing is that students that often come from these environments require additional support in subitizing. And the reason for that is their lives are so untrustworthy or so unpredictable that it translates into parts of education. So when they're being asked to subitize and tell me what this dot pattern is without counting, sometimes they just don't trust it. They don't trust that every time I look at an arrangement that's a 5, it's going to be a 5. They want to fall back on that counting because they know that is the best way to get the correct answer every time. It takes a little bit of a leap of faith to get to that instantly recognizing. Okay, so that's just something to keep in mind. Now, I always get the question from participants, well, how do you work on that? And again, it's just exposure. It's constantly reiterating to them, when you see that 4 die pattern, it's a 4 every single time. Do you want to count it? If you don't trust yourself, you can count it, but I promise you it's still going to be a 4. Or even saying, just tell me what you think it is, and then we'll go back and count it. So they just need opportunities to develop that trust. And then of course there is conceptual subitizing. So that is the next step. These are usually where like your kindergartners will come to you at, they may be on the bridge of perceptual and conceptual. This is where students are starting to naturally apply mathematics strategies such as grouping in order to do subitizing. So here you see an example of a 7. So they will recognize that's a 7 because I see a group of 3, and then 1 in between. This requires students to have a more stronger sense of number sense because they have that solid foundation of what numbers 1 through 5 look like. But again, you could have students all over the place with this. If students don't have a large experience, a solid experience in perceptual subitizing, you could be a 2nd grade teacher and you're still working with kids that are going and really trying to really become confident in those 3 through 5. And there's nothing wrong with that. It just takes encouragement and repeated exposure. Okay. So with that, we are going to take a look at an example. Initially, when we defined subitizing, we looked at perceptual. All those images were 5 or lower. Here, I'm going to show you an example of more of a conceptual subitize. And this is something that I would do in a classroom, depending on what my early childhood kids were doing with their subitizing. I might throw it at them. But definitely appropriate for a kindergarten classroom through 2nd grade. So once again, I'm going to throw an image on your screen, and I'm interested to know how many you see and then how you saw it. So kind of a 2-part question. How many you see and how you saw it. Right? Here we go. All right, that went pretty fast. How many did you see and how did you see it? I'll do it one more time just in case. There you go. All right, 7, 4, and 3. I have an 8 there. I have a 7, a 2, and a 3. All right, very nice job. Okay, so this is the pattern that was shown. And what I like about this is that this is, again, a cheap and easy, yet very impactful activity that you could do in your classroom starting on Monday. So when we talk about math talks, how do you see this number is a great way to begin. Math talks we know are very valuable because they encourage kids to take risks, but they also set the tone that in math class, there are a variety of different ways to get to answers and a variety of different ways to see math. And in the last session, we talked about the difference between being a mathematician and being good at math class. And those types of experiences where kids get to talk about how they see math supports a mathematician's idea of mathematics and gets away from that perception that math class is all about being fast and correct. So with that, here's the example that you saw. Some of you said that you saw 7 dots, which when I count those one by one, that is absolutely correct. And here are some ways that you may have seen it. So I know that you listed a few. You may have seen it like this. So a set of 4, a 4 die pattern with 3 individual dots going through the center. And I know that 4 and 3 is 7. So doing some conceptual subitizing. The next one is I could have seen this as a 5 die pattern in the center with 2 dots on the outside. And 5 and 2 is 7. And then finally, I could see this as a set of 3 and a set of 3 with 1 single dot in the center. I think some of you said, let me see, let me go back to the chat, 5 and 2, okay, good, Robin. And then, yeah, there was a 4 and a 3, good, and a 2, a 3, and a 2. I'm going to assume that that is 2 on the top, 3 in the middle, and 2 on the bottom, if I had to take a guess there. But there a ton of different ways. So there were 4 different ways that we just talked about. And I like this because it's a quick and easy way to subitize. Kids are doing conceptual subitizing while also practicing that perceptual subitizing. But an example of this is actually included in, if you also follow Jo Baller, she is another great math educator. And what she does with an activity like this that I really like is she takes it and she will show students the initial pattern, and then each student gets a different color marker. And what they do with the different color marker is they draw, like even on just a large index card, how they saw that arrangement. And then she takes everyone's index cards and puts them on the board. So students kind of have like a huge gallery of the variety of different ways that young mathematicians see mathematics. And I think that that not only is a great way to subitize, practice subitizing, but it is a lesson in what math is really about. And it's not about getting that right answer, although that is an important part. We want, correct answers, but we also want to value the process to doing that. So if you're looking for a way to really continue to support your students in their math confidence and their math abilities beyond basic academic parts like adding and subtracting, that is a great example. I love the idea of kids being able to draw what they see in their mind and then share it with the class. It's a good activity there. And to show you kind of what this also looks like for those of you that work with really young kids, 4-year-olds are able to talk about this. Kids that are just turning 4 are able to discuss ways that they see math. So give kids, ask them the question, well, how did you see it? In this example, there was a 5, and this student did some conceptual subitizing with a 5. They saw a 5 as a set of 2 and 1, right? So 2 on the top, perhaps 1 in the middle, 2 on the bottom. And then it looks like she may have oriented it a different way and saw 2, 1, and then 2 on the other side. And then Omar, he saw 4 with 1 on the inside, and he knew that that was 5. So even with your really young students, you can talk about the way that they see math. And I know that this is not a new concept. My daughter is she turned 6 in October, so she is in kindergarten. And I've been thrilled that she comes home. I think that she is probably going to be a teacher or a librarian of some sort. And she comes home and she repeats things that her teacher says. So one day she came home from school and the entire family did a subitizing. How do you see this number? And I was thrilled that she even, so remember that a lot of times what you do as teachers of young students translates and gets taken back home. So it's also great for your parents to see how you're talking about mathematics, because that's easy and it's fun for them to get that connection between the two. All right, so why should my students be doing this? In the previous session, there was a comment that sometimes it's hard to get everyone on board about why this is important, and we're gonna look at that. First of all, it's important because of the development of pattern recognition. So when we think about our math foundations, patterns is one of them. Shapes and spatial reasoning is also one of them. And when we look at especially die patterns or patterns on a 10 frame, there's a geometry component there. And so we're respecting that and acknowledging it as those are all integrated parts of mathematics. The next is understanding of numbers and number sense, of course, the number sense part, but subitizing also builds things like numerosity, understanding what numbers truly mean. When I say the number 3, I am talking about an actual quantity of 3, not the number 3. And so numerosity and quantity, also looking at cardinality. It also builds a foundation for algebraic thinking. When you think about what students are doing all the way through high school mathematics, it is all based on their understanding of how numbers work and developing that number sense. And I talked a little bit before about how number sense is so important because it allows kids to work with numbers flexibly and efficiently. It also allows them to be better sense makers. So proficient mathematics are good sense makers. They're really good at reasoning. This is why when you get to middle school into high school, students turn in or give you answers to math problems and you're like why do they not see that this is wildly incorrect? There is no possible way that this could be the right answer. So students that struggle in those areas, they lack that number sense. And it all begins with how students explore numbers at an early age. We also say that it is efficient. And this is where I'm going to make my case for counting versus subitizing. Efficient means flexible. So students have a variety of different ways in order to arrive at a problem. We could make the argument that when we look at standards, so like Common Core standards talks a lot about being able to recall facts from memorization. That is actually written in standards in first and second grade. Being able to add to 10, being able to add to 20. From memorization though, does not mean from memory, which means when we revert that back, we think of flashcards and just memorizing math facts. And that is, there's an argument that that is efficient. However, if students aren't able to do that, they are struggling. And that is not, we do not want to make that just the only benchmark and way to do mathematics. So I'm going to make my case now for counting and subitizing. All right, I can't see you and I can't see what your fingers are doing. However, I am interested in, if I were to ask you to show me 6, take your fingers and put them on your screen and show me 6 on this number line. Go ahead and point to it. Where's 6? All right. Now, before I go on and tell you if you are right or wrong, which this is a group of math educators, you probably are correct. However, if I was to do this at a general conference where there are a variety of different people here, I would guarantee you that half the room would do this wrong. If I was to ask my husband, who is a very intelligent man, love him a lot, if I was to ask him to show me 6, he would probably get it wrong. This is an example of what's called a number path. For those of you, well, all of you, since you are in primary grades and early childhood, check out the value of a number path versus a number line. It is a great tool because number lines are actually very abstract for students to use. Number paths are great. And you can see here that this number path, it focuses on friendly numbers of 5. The first 5 are in one color, the second 5 to make a group of 10 are in a different. That's a different PD for a different day. However, show me what 6 looks like. If I was to ask a general room of people, this is what they would say. Here is 6. I know that number. It's a 6. But what we want students to understand is that when we say 6, 6 is not just the number 6. 6 is equal to numbers 1 and 2 and 3 and 4 and 5 and 6. It is that understanding of quantity. 6 is composed of all the numbers from 1 through 6, including 6. And that's important for our students to understand. And here is why. When we look at higher level mathematics, and by higher, I mean we're getting into concepts that are explored in kinder, first, and second grade by definition of the Common Core standards, or most standards, depending on what state you're in. Let's look at a problem like 6 plus 7. This is probably something that I would see in a general classroom where students are working with numbers less than 10 that add to 20. All right, so 6 plus 7. For students that don't have strong skills in subitizing, here's what they see. They say, okay, 6 is equal to 6 individual units plus 7 individual units. And there's nothing wrong about this representation. In fact, when my daughter brings home her iPad and we sit and do the math together, because I'm very interested in what this looks like, this is often how I see that she uses counters in this program that she uses. individual pieces. Now, this represents counting. So a student that is doing 6 plus 7 using primarily counting strategies lays these out. This is very difficult to translate into higher level mathematics because it is linear. There is not much that's efficient about this. In order to do this problem, the student has to lay out those blocks and then they have to count individual pieces, which when you're doing 6 plus 7 doesn't take that long. But what if you're doing 36 plus 17? Now you're lining up in a straight line 36 blocks plus 17 individual blocks. Eventually that becomes inefficient. So the only way that students can really solve this problem without strong subitizing is either by memorizing it, which is the lowest level of skill on Bloom's taxonomy, or by counting, which again becomes inefficient at some point. When we look at the same problem for students that have strong subitizing skills, such as using 10 frames, here's what they see. They can think in their head and they can picture, because remember, subitizing is all about being able to picture images in your head. 6 plus 7, I know what a 6 looks like on a 10 frame, I know what a 7 looks like on a 10 frame. And if I have to add those together, the only strategy I really need to use, and it requires very little individual counting, is now I can make what we call friendly numbers. I can fill a 10 frame, and that's so easy for me to do. And the only way I need to do that is by moving some of my counters up, make a 10, and what I have left is equal to 3. So 6 plus 7 is 13. It is not in a linear form. I can easily add larger numbers here by making friendly groups of 10, and I can do it in my head. I don't have to count out individual linear rows of blocks, okay? So that's a very basic example of something that perhaps at a kindergarten, first, sometimes second grade level, your students may be exploring. Now, how does this apply then to older students in second grade? Second graders are learning how to multiply. They're looking at basic foundations of multiplication. Well, for my second grade teachers, here's what you're seeing, okay? Often when we teach multiplication, we do a really good job of trying to support students in that concrete representation. And we do that by giving them manipulatives. So when we practice things like, here you can see it is 3 times 6, so 3 groups of 6. We give them tiles, we give them counting bears, we give them counters, whatever they might need in order to represent what 3 times 6 looks like. Then we ask them to translate that into a more abstract representation where we just use the numbers, and 3 times 6 obviously does not equal 30. So the jump is big, it's too large. Students can usually perform well using the manipulatives, but then when they're just given those flashcards with numbers where they have to memorize things, they're not able to make that connection between the tiles to the cards in the numbers. So subitizing can be really helpful in this sense because it is kind of the middleman. So here's an example way that you could use subitizing to develop multiplication with your students. We want to have them always have that opportunity to build using concrete models. Then what we can do is introduce what is like multiplication subitizing cards. And this takes it from the physical manipulative part, the concrete, to a representational, where they're still seeing images and parts. They can't manipulate them, but they're still seeing them. And then that bridges it to the abstract of only having the numbers. So it's kind of a good middle piece. So I'm going to introduce this this resource. These are multiplication subitizing cards. Again, not appropriate for my preschool teachers, but excellent resource for my second grade teachers. And again, if this is something that if you're really focusing on subitizing in your entire school, these are all bits and pieces that layer on top of one another. But I want to show you how these look in action, okay? So this is a video by Graham Fletcher. I'm going to type his name in. I have all this linked for you as resources in your, at the end of this presentation. He is using multiplication subitizing cards with his daughter. And what I'd encourage you to notice is, if you were like the evaluator here, what are some things you notice about what she is confident in, what she has perhaps become proficient in, and what is she struggling with? But also, what opportunities do these cards afford you besides just having another resource to use to support multiplication?
$20. 12. 20. 30. 24. 18. 15. 6. 10. 6. 8. 12. 10. 35. 4. 21. 25. 36.
How did you get 36?
I know that 6 plus 6 is 12, and so these are all, both of these are 12, and I added these together as 12, and I added 30, 24 plus 12 equals 36.
All right, so there are a lot of things for you to see here. First of all, I want to recognize that these multiplication cards, what's again, higher level second grade, well, not higher level second grade, but within this span of people are attending this session, second grade, you are relying on early childhood teachers and kindergarten teachers to really practice what that perceptual subitizing here is. Here, I am relying that students understand, first of all, what a set of 4 looks like and what a set of 5 look like immediately without having to count those. So it builds. The next step then is that I'm thinking about that multiplication piece. So here, what I can pull out, which I'm sure was probably evident, was that she was more proficient in some multiplication facts than others. By doing this, I can gain as much information using these representations with this student that I can with a timed fact test, which does nothing but provide a stressful environment for a child. So I'm able to see which math facts she's proficient in and which math facts she perhaps needs more support in. You also saw in the last example here, they asked, Graham Fletcher asked the child, explain it to me. And we were able to hear her thinking, and she was able to do some grouping that allowed her, she used some repeated addition and grouping in order to figure out what the answer to that solution was. So these are just a really easy resource to have. And again, they are free. These multiplication subitizing cards are 100% free. And I'll give you that link at the end. So this is, we started very easy with Flash It, just showing what a 2, a 4, and a 5 look like. Then we did some addition, how subitizing influences how students are flexible with addition strategies, and then how this then correlates and leads to higher levels like multiplication. So how do we get started? Well, again, there's a lot of different ways to support students in developing their number sense and their subitizing skills, and they don't all have to be during mathematics, right? Now, some of these, again, we talked about in the previous session. but some of them are also new. So the first one that I want to show you is just classroom routines. If a math talk is part of your classroom routine, that's fantastic. It's a great, again, low cost, high reward activity to integrate into your math routine. There are a couple of different examples here. The first one is how many dots do you see? We did that together with the set of 7, where you talked about how many you saw. Again, this is the activity where I told you about using the different colored markers where students draw it, and then we put a collection up on the board for them to show how they see a number. And these are really easy to do. You just make them in a PowerPoint, throw them up on the board. Doesn't get much easier than that. The next is with subitizing cards. So here's an example of the multiplication subitizing cards. There are also the geometry subitizing cards. There are fraction subitizing cards. There are lots of different kinds of subitizing cards. And they all practice a variety of different things, and they're all easy to be, you can download them for free. And then the last one there is what we call number strings. And you see here a set of 4 numbers. Number strings, and it kind of like builds up to itself. So first students would see that set of 4, and then in the next part, they would see a set of 3 added on, and then back to 4, and then up to 5. And students here can look at patterns. There's lots of things you could have them do. Extend the pattern. What do you think would come next? Talk about what you think the rule is. How could you represent it a different way? So number strings are also building that understanding of number and quantity. Attention getters. So we're always looking at ways to get kids' attention back. Show me 4, show me 6, show me it on 2 hands, show me 1 more than 4, show me 1 less than 4. A variety of different ways that you can quickly have kids represent quantities using their fingers. The last one here are brain breaks, which I know are very popular and appropriate to use, especially with young kids who sometimes need that opportunity to get up and stretch their bodies, move their bodies when they've been engaged in activity for a while. These are, and Jack Hartman is a really popular artist that does some great videos that are for brain breaks. My kindergartner comes home and plays Jack Hartman on our Alexa almost every single day. So I know how great Jack Hartman is. We do the count to 100 and the, I don't know, there's a bunch of different ones. But Jack Hartman actually has some subitizing songs. I mean, how fantastic is that? So these go, I can count to numbers in so many ways, and he kind of like shows different representations of numbers. There's a subitizing rock, there's a subitizing rap, subitized to 10, subitized to 5. Unfortunately, I haven't found any that go beyond 10. So this might be great for like your younger students, or you know what, even your older, I mean, it never hurts, right? Like it's always good to continuously practice and do a spiral review. So you might find these valuable, but I love them because they're fun for the kids. And again, you can subitize at any time of the day. So that's a good resource there for you. The next one that I want to show you is an example of how you can do it during transitions. I shared this in my initial video, so I want to make sure to include it here for those that will also be watching. But what I love about this video is just that it's super easy to put together and a great way to use subitizing, again, outside of the mathematics time and in other parts of the day.
Okay, my friends, so to go to gym today, I'm going to have you tell me how many dots you see. Are you guys ready? Leon, do you want to go first? Okay. Okay, show me how many. Oh, I see that you showed me 3 fingers for 3 dots. Go ahead and go sit by your locker. Okay, show me how many. Yeah, I like the way you showed me 3. 3 fingers for 3 dots. Okay, Arnold, are you ready?
What? I didn't see you.
He just got here. Okay, Arnold, you're going to show me on your fingers how many. Are you ready?
Arnold, did you see you?
I see that you show me on 2 hands. You show me 2 and 1. That is 3 for the 3 dots. Go ahead and go to your locker. Jordan, are you ready? Okay, show me how many. Oh, good try. You showed me 4 fingers. There are 2 dots. Go ahead and go to your locker.
All right, and I appreciate that time because I needed to plug in my battery there. Rookie move. So what I love about this is just the materials are easy: binder, ring, index cards, sticker dots. I also like because this resource students can touch. I didn't mention that previously, but you may have noticed in a later example, she asked a student for, I think she showed a 4 and he said 3, and she said, she held it and she said, oh, I see 4 dots. And she took her fingers and she physically touched those dots. So again, earlier we talked about some students just need that reinforcement and opportunities to build trust that the number that they see is what they think it is without having to do that counting. And by being able to come and physically touch that and say, oh, that is 4, also helps reinforce that. This is also good for students that are at various places in their Subitizing journey. You can have students who are working on 1 through 5, you know that, and you can flip to those cards, or perhaps larger numbers, 6 through 10, you can flip those cards. So it can be used a lot of different ways, and it's just so easy to do. I know that, like, especially in elementary school, when you're transitioning from like your classroom to a special and kids are lined up on the wall waiting to get in, you can just take those and go down the line. Nice little Subitizing activity. So lots of different ways to practice that. Small group games and activities. So here are some additional examples. Any game that you play with regular cards can be played with Subitizing cards. Memory war, you can sort them. If you're an early childhood teacher and you have just the basic Subitizing cards with a variety of different representations of numbers, you can have them sort based on the number or by the representation. If you have older students, even those multiplication cards, sort them based on how many groups they have. You could have them sort it by their product. You could have them play Go Fish. I mean, lots of different options here. The next example is bingo. So, I mean, bingo is fun. Who doesn't like bingo? Here, students are taking, and again, can be modified based on the level. So here I see there are numbers that are past 10, but even if you're having students work on numbers 1 through 5, your bingo card shows multiple representations of 5. You can call it out, and it doesn't even have to be like the exact image. So for example, like it doesn't have to be a die image of a 5 where it's only a single space. You could just say 5, and then the students have to cover up all of the pieces on there that have a 5, where it's like more of like a blackout thing. Who can cover their bingo card the fastest? Another one is I have, who has. If you haven't played this before, this is an oldie but goodie. This is a fun one. Each student in the class gets a card and they have a representation, and then they have to ask. So you could say, I have a 5, who has a 3? And then another student in the class has a 3, and then they're looking for someone. So I have a 3, who has a 17? And then that student, whoever has a 17, and it continues until you get to the very last person. So those you can easily make just on Word or whatever. It's very easy to find representations of numbers. If you just do an image search, a Google image search for like finger representations to 20, you'll see them. And what I actually like about those is that as we support a variety of different learners, they come in different skin tones too. So it's just a great way to continuously build in that understanding that mathematicians of all backgrounds, ways, you know, brown skin, black skin, white skin, everything in between, everyone's capable of doing mathematics. The other example down here that I have is which one doesn't belong. I shared this in the previous session, the example of the dominoes. And what students do here is they just identify which one of those doesn't belong and why. It's a great way to support talking about mathematics. Then we have Tiny Polka Dot, which again is another resource, can be checked out at your library or purchased on Amazon. Here are different representations of numbers, both die patterns, 10 frames. There is the green and the blue dots for composing and decomposing. And then there are cards there that suggest ways to use it. So from most basic preschool ways to use the cards to more advanced ways. And then finally, one that I like, which is just an easy small group one to do with like a partner, is roll in circles. So students are using dies. And remember, there are more than just 6-sided die. You can get a 10-sided die. You can get a 20-sided die. There's lots of different kinds. And students roll that amount, they look at that quantity, and then they circle that amount in some geometric pattern. There are also some great resources on how to integrate number sense into STEAM and into literature. So How Many is written by Christopher Danielson. I do not think I have the book here. I have a couple copies of it. My older daughter tends to steal it. But How Many is a great resource. Christopher Danielson also did the Which One Doesn't Belong. And in this book, it's just beautiful images of like scenarios, like 2 pairs of shoes. And the question that students talk about is how many? How many do they see? Well, I see 2 pairs of shoes. I see 2 shoelaces. I see 20 of those, the round things, are those like eyelets or something that the shoelaces go through. I see 2 tongues on the shoes. I see 4 stars on the shoes. So students just looking at images and pulling out that mathematics. The next one is 10 Black Dots by Donald Cruz. This is a good one for younger students. It's just ways that 10 dots can be arranged, and it's kind of like a cute little story that reinforces ways that numbers can be represented. Another way is to include subitizing cards and centers in math areas. Again, anywhere that you can put numbers, you can put these cards. So like imagine your sorting station. Ask students, well, how many items are in this collection? And have them assign a card to it. So we have these cards for our early childhood program. These are just number cards. You see the 5, the 2, the 10, and the 15. And these cards have both the numeral, but also the die pattern. And we give them to teachers to just try to use in a variety of different ways. You could use them to look at quantities in a sorting table and then compare those cards. You could use them, we use them on our ramp center or our block center to represent how far cars go. So just giving students access to resources that encourage subitizing. You'll also see on the far right there, that is actually what an activity that we include in one of our block centers. And it is kind of like a menu. So the students have access to different colored Legos, and they are given there's a whole bunch of different cards that have quantities on them that tell them this is one building, and this building is made of 3 red Legos, 1 blue Lego, 5 green Legos, and so on. Students collect those quantities of Legos and build a building with them. And again, it's just a good way, easy way to incorporate. Remember, anytime you put a number down, try to show it a different way. Don't put the numeral down, put the tally mark down, put a 10 frame down. I've seen teachers even on their calendar use different representations of numbers. So lots of different opportunities. Then the last one that we have then is the sensory exposure. And this is great, especially for my preschool teachers. I know kindergarten teachers often are still able to support sensory learning in some shape or way or form, perhaps not with a necessary sensory table or bin, but in other areas of their day. Here you can see this is an example of a demonstration of what 6 is. So 6 is equal to, you see the die pattern there, you see the numeral. We gave them loose parts. They have buttons there. You can use anything to represent or use loose parts in. And then they had that tray where they wrote the number 6, which would, again, be supporting even in kindergarten, looking at some of those high frequency words, those sight words, making connections between the written word and the numeral and the quantity. So here are some of the resources that I've referenced. Again, when you download this session, all of these will become live links that you're able to kind of check out very quickly. There are a few articles that I've referenced throughout the presentation that are included here as well as some organizations that are great for supporting number sense. But before we leave today, any questions on building number sense? I'm glad that many of you were able to make it back. I hope that you gained a little bit more of an understanding of how beneficial subitizing is and how you can support your students in it. While you think of that, I'm going to go ahead and put in your evaluations for today. The first one is the ISB, the state evaluation for you. And the second one is the presenter evaluation. And I will, again, write my name. And this presentation is building number sense with subitizing. And there's the link for that. But as you take care of those items, here's my contact information. Well, that's where you can download it, or again, you can go back to the page in order to download the session. And here's my contact information. I do want to just share that after lunch, I will be holding my last session, which is on using 3-act math tests. This will look at what 3-act math tests are in kindergarten through 5th grade. If you're an early childhood teacher, the example that we look at for kindergartners, I think you could easily adapt for early childhood students, or at least take a stab at it. Never hurts to try. So feel free to join me for 3-act math tasks if you are interested. And again, thank you for being here. I appreciate it. It's always great to talk math stuff. Never gets old.